Hello and welcome to the fifth part of the Block C in-depth explanation videos. This time we'll be going over the fifth and second to last part, which is the arch placement system. So this was mostly a sort of a proof of concept. This was just to show, okay, these are some room shapes already managed to get into the final system. To just dive right into it, the first step I take is use this separate arches node, which is a custom node I made. So that's basically this thing. So I found it necessary that for the project I would be able to quickly just switch between rooms. So here I can just switch between room types just really swiftly, and then disable certain elements. So here I disable the pillars, arches, and doors. I think I left something turned off. Yes, I did. So there we go. Let's turn this on back again. So here I can just quickly switch between viewing, for instance, only the door points, only the arch points, or only the pillar points. And as a very simple setup, it just checks what type of group is in there, and if it matches that group, it just either does or does not delete it. Which is then used in here. It's set to just arches. So I then loop over all rooms. So let's start off with the corridor. Similarly to the instance or placement points before, these systems are all very similar because they're all doing kind of a version of the same thing. So I'll be picking the most interesting ones, in which case I actually have to switch around a little bit. There we go. So this is the round room, and it can be divided in a couple of sections. So here we go. Let's actually start off at the first part. So the first thing I do, if you go to the grid, you can see that this room is not placed at 0, 0, 0, which is the first thing I move. I just use the bounding box information to pull it back to 0, which comes from this info node here. So I use the info point, the bounding box of that, and just move it to 0. So I then separate the arch points based on arch type. So here I use the type function, or the type attribute, which I think is somewhere in here. Here we go. So here we said place arch ceiling round walls. I take out that tag word walls, and it's separated into wall arch points. Here we have the ceiling arch points, and here we have the ceiling inner arch points, which are kind of lifted up there. So then we get to the actual placement. So this is just a bunch of copy nodes placing arches. Not much interesting happening here. The end result, however, is pretty interesting. So this is how that end result looks. And as you can see, some of these covers were added, which is what happens in here. But first I resize the arches. So when I get these, they're differently sized. So the ones that point in are a bit bigger because they need to cover more distance, so they need to be larger. And to kind of get a similar size, I use this. So what this does is it takes the highest position from this group. So you can see here these inward pointing arches have a certain height. I take that, take the, so let's just turn on primitive numbers here. All of these arches have separate primitive numbers. So if I promote the maximum y value to the primitive number, you get the maximum y value relative to the primitive. I then use that to make a scale value. So what it does is it just takes the tallest point from this one. So this is the tallest position here. Whoops. It takes it into here. It looks at the current maximum y. So if you open up the geometry spreadsheet, you can see that on the primitives, there's now also a y value. Or actually a position value. So I use that to, first of all, I uniform the scale. So how that works is you just do 1 divided by the maximum height. In this case, let's see, primitive 5. The maximum height is, well, apparently all the same, so 5.02. So you get a value between 0 and any number actually that has to be scaled. So if you multiply 1 by that number, you get this size, which is fairly simple. I then multiply that kind of uniform measurement, you could say, by the tallest height. So now this, if I would apply this to a primitive, it would mean that the height would be exactly 1. So I then multiply 1 by the tallest height, and then you get a scale value. So here you can see that it's 1.7. I then loop over all the points on the primitive and multiply the position of the point with that scale value. And that's how I get the adjusted height. So here I just resample it because there's way too many points on here. And there we go. We get those similarly sized arches. Now, then we move to the covers. So this is a fairly simple, oh, wait a second, before we move into here, let's quickly look at here, because here I do some stuff to sort everything. So as you can see, these are made out of 2 arches. So these are 2 points that are pointing towards those inner triangle points and make an arch. But that generates 2 different arches, or half of them. So what I do is I sort them, which in here it doesn't do much. But if I turn on the primitive number, the point numbers, boy, that's a lot of points. You can see that they change on some primitives. So that's what I do in here. I use a switch node to see if the primitive number is either divisible by 2 or not. If it is, then I switch to non-sorted. If it isn't, then I switch to sorted, and I reverse the point order, which is then used to use a join node or an add node. So what the add node does is it can just delete geometry and only keep the points and add them again, but the point order needs to be correct. So if I actually turn off this sort part, you can see that it has this line kind of sticking through, which is not what we want. So yeah, using that sort thing, it does that. And then just do some grouping, and yeah, there we go. Now really moving on to the covers. What I do here, it's fairly simple. I move over every pair. So this is a pair of arches. I think I even have an attribute for that. Apparently I do not. Oh right, yeah, the primitive attribute. So these primitive attributes match up depending on if the arches match. So using that attribute, I think it's down here. Oh, it apparently doesn't. Well, that's interesting. All right, yeah, here it happens. So I basically just move them together, and again I reverse it. So this is a thing with the skin node. It can basically loft between 2 or multiple curved surfaces. So for instance, in this case I use a polygonal curve, but it can also be a NURBS curve or a Bezier curve or whatever. But if I don't do this, then sometimes it messes up. So in this case we were lucky, but here you can already see that it messes up. And for some reason it's always on the last iteration, I think, on the first iteration. So on the first iteration it always messes up. I'm not sure what it is, but for some reason it just likes to do that. So here I add a reverse if it's the first iteration to fix that. It then fetches everything together and it does that. So yeah, that is the round room arches, and last here it moves it back to the centroid using this info point bounding box. So that would be the interesting parts from this. The rest are very similar. Looks very interesting when you use other parts. So the rest are very similar, the setup. So again, imports points, separates them, places arches, tries to make roofs. Here I didn't finish it yet. This system, by the way, is work in progress. I moved over to the proof of concept, which what the next video is going to be about, because there were numerous mistakes and I didn't have enough time to fix them, so I thought to just make a visual proof of concept to show that, yeah, this is what the visuals are going to be. So yeah, very similar setup all over the board. So that would be the arch places, or place arches. For the next video and the last video, I'll be going over this system, which is the proof of concept system. So yeah, thank you very much for watching, and hopefully until the next one.